Hello again. My name is Alan, if you haven't been here before, and this is lesson 26 in the series, which apparently has to do with C++, although if you're following this, you know by now that C++ is our goal and not our starting point. So, continuing on from the last lesson, I'd like to take a look at the command line and what's involved in parsing it, that is, in breaking it down and separating it out into the various bits and pieces that you typically see in a C program. In a C program, it always starts out like this. Include some file. And if it's a console program, I'm not going to be particular about what's const and what's not const or anything. This is just the shape of what you get. The first argument is always an integer, and the second argument is a pointer to a pointer, or to a bunch of pointers. That is, if you look at this argv in memory, you would have maybe the zeroth. So that this is like a big list, an array of pointers. And each of these pointers is a string value. So each of these pointers points to an address in memory of a C string, which means null terminated string. And so on. So all these the same. One of the great things about this DOS editor is you can do this. Every other editor in the world I've ever used would leave the cursor on the end here. But you can do what I just did there with this one because it stays in place. I wish that was a feature. Anyway, I'm diverging. Okay. Now, so that's what gets passed to main, and a lot of people like to call this the command line or the command line arguments. But that's not what is actually passed into the program from the operating system. This argv is prepared by the C runtime before your program gets entered, before main, and it fixes it up in this nice format where it's an array of addresses. In fact, this again is a divergence, but there's more to this than meets the eye. I was curious because, and I had a video containing this question. A lot of people write it in this form. That is an array of strings, which is true. That is what this is, an array of strings. Now, this is where people start to get confused, I think, between what it means to say an array and a pointer. What's the difference between those two things? Well, in a way, there's no actual difference. But in a function declaration like this, something like this, my question is, or should be, and so should yours, where is the data that this array contains being held? That is, it's possible. If this is supposed to, this is the stack, which I've always drawn this way, that the pointers are actually on the stack. 3, let's go backwards. All right. Okay, that is a possibility, and that in order to make it all work, there is the address, this address, call this, whoop, not that one, this address. Here. So this could be the address of PT R0. That's possible. Now that would have the same effect as another scenario where somewhere in memory, unknown, there's an array of pointers. So somewhere in memory not on the stack, let's say could be static memory. As an example, there is an array of pointers, and it's possible that this here points to this. To this array. And that the rest of this is empty. So there's only, well, there's an integer too that I forgot to put before. Oops, cool. I guess it would have been I had it upside down. So the other, let me just do the other scenario quickly. Zero, zero. Trying to go quick. There. Oh. So that means that this one really would just point to the next element on the stack. So that's one possibility, and here's another possibility. And I was curious. I know I'm diverging again, but I was curious to know which of the two scenarios it is. Is it like this scenario? One, or a new scenario which doesn't include these. It's actually bars here. You know what I mean. And not that. It's just argv. Points to some address in memory somewhere. Could be in the heap, could be on somebody else's stack, who knows. My question is, how can you test that? Well, first, let me just point another thing out. How can you actually pass an array on a stack? So forgetting about this for a minute. Suppose I have a function h. I'm going to compile this. Foo, let's call it. And suppose I'm going to say it takes an integer array of 3 elements. Okay? Oops. And I'm going to print them out. This is an int. Or 0, 1, 2. Okay? I'm going to call this main.c. And here I'm going to have an array of 3 ints. I'm going to choose some random numbers. I'm going to call foo with my array. Now that should compile. Oh, yeah, the other one. So, let's see what the compiler has to say about this foo and that array. Oh, a lot of things scrolled off the screen, but the most important bit is down here. Here's the setting up the stack frame as normal. An address being loaded into the AX register. That's what this is. A single push, one object, a pointer, and calling foo. And then only adding 4, which in our case would be 2 bytes, to restore the stack. So this array here is not actually being copied onto the stack, which is what this statement should mean. I mean, I could declare this as a pointer to an array of ints, but it's not declared that way. It says an array of ints. Well, that got me a little bit curious. For one thing, if this was an array, I should be able to determine the length of the array, even if I didn't know this number, this way. The size of the whole object divided by the size of one of the elements. I could say int here. Okay, int. Now that should give me the size, the number of elements in the array. So we can add that to an R1 here. I didn't actually run this. I'll run the previous version and then compile this and see what we get. So actually I can run the current version. Okay, here's what the current one gives us. The 5712 I passed in. Now I've changed it. And I've added an extra thing here to tell me, I've added J, which should tell me how many elements are in the array. Okay, let's compile that, see what happens. Well, it says there's only one element in the array. So it's truly, absolutely, 100% truly, a pointer. However, and this got changed somewhere in one of my mistakes, we're still left with this declaration and those two possibilities of there actually being an array on the stack, as in the case with printf here, which is, if you look at that output, printf here is getting lots of things pushed on the stack. In fact, the whole array is getting pushed on. And I want to know if there's a way I can determine if that's what's happening in main. And the reason I would think that might be a possibility is because main doesn't have a prototype. So it might be possible, even though it seems impossible to pass an array to a function normally through this type of declaration anyway. Main doesn't have any declaration, so you can do whatever you want. And it's possible that this actually is an array of pointers on the stack. And this first bit points to the next element, the first element of the array. But I had a hunch. And first I wanted to prove it one way or another. If this were an array on the stack, and I declare this as not an array on the stack, but just a single pointer, then if I put a comma here and add another variable, something, it should be an address on the stack. So the first thing I could do is just see what kind of if it's an address on the stack, sorry, it would have been the, yeah, this is a car star star, but no, actually it wouldn't, I couldn't tell that way. But one thing I knew for certain was that if all of these elements are laid out here on the stack, and I try to print out something from here, I'm either going to get garbage because I made a mistake, or I might get one of these elements. But but because of this sort of thing, I'm 100% sure, almost 99% sure, that this is just a regular old pointer. And I had a theory or a hunch that there might actually be extra arguments on this stack because there's no prototype. And I was looking at this format and I thought, maybe there's another one of these on the stack. So I declared one. Another pointer to pointer of strings. Pointer to string, the string array, which I'll give another name. Call it big these. And then should I do that or okay? Get rid of this. I'm gonna write a completely different program. Save this off over here. Get back to it. This diversion is going to become the actual video, I think. Now, here's something that you probably don't know, and I happen to know just by experience. So this is C, so I can't declare things on the fly. The last element of this argv is always no. So I can do this. This is I don't need to use argv. And if that's true of that one, it's probably true of the other. I'd like to pause between these two because I think you're going to find the result quite interesting. Need some console support. Con. I want to just put a pause here. That's a con IO4. And now I'm going to do the same loop with this new argv, which nobody's ever told us about, but I think is there. And, maybe I'll just draw, wow, I'll leave it like that. Okay, so this prints out the first argvs, this prints out, if they really exist, the second argv, and we'll compile that. Okay. Oh, that's okay. I'm going to supply some arguments. Here's an example of one of these weirdo things. What? Okay, I got it compiled it. Okay, so here it has printed out the arguments. You'll notice, by the way, that that I think thing happened, that it considered those to be together. But anyway, not important. Is there anything in the second argv? And there you go. It turns out that that's the environment. Those are all the environment strings. So in fact, main here takes has a third argument, and who knows? Maybe there's more. But I'm not going to test that right now. Well, So we found out we found out anyway that, and another thing, which is that this here is a lie. If I go back to this main, and I really want to tell foo how many elements are in that array, I've got to work it out myself. Pass that in as another argument to foo, and now you're starting to see why there's an argc here in main, because there's no way we could figure out the size of this array if it were an array. Get rid of that. I'm going to change this here to C, and if I compile this, there's J. Whoops. O-A-R. Now it knows that there's 3 elements. Otherwise there's no way that it would have been able to tell how many elements are in that array. I don't know what other people think, but to me, this is a lie. This is a compiler bug. This says that that's an array of 3 elements. There's no other way to interpret that. Int, array, bracket, bracket, 3 elements, just like this. This calculation, size of over size of int, for this thing, which is declared in exactly the same way, should return the same result. But instead we get 1 when we try that here, and we get 3 when we try that here. This array, according to this declaration, and I don't care what this spec says, any normal human being looking at this declaration would have to say that this is a copy of this array. All of these elements should have been copied onto the stack before foo passed in. As it is now, foo here could actually change the elements in my array. But I'm not passing a pointer to my array. I'm copying it. At least that's what this would normally mean. It is possible to pass an array, by the way, to a function. That's something that's come later. Well, now I've over-diverted in order to cut this off and continue the other discussion where we were going after this. It's too long. Okay. I'll see you in the next one. We will get there. We'll get there.